You've probably admired beautiful mountain landscapes. Perhaps you've seen pictures of a volcanic eruption. Or maybe you've witnessed steam streaming from the earth, or even boiling water shooting out of the ground. Or maybe you've experienced an earthquake, or seen a picture of the devastating damage earthquakes can cause. What do all these things have in common? All these exciting events are related to the dynamic movement of the Earth. The view of Earth from space shows a mostly blue planet dominated by water. That water is interrupted by large pieces of solid land called continents. Look closer, and the continents look like pieces of a giant jigsaw puzzle. They even appear to fit together. People throughout the ages have wondered if this was a coincidence or if there was a deeper explanation. Other questions perplex scientists, such as why are fossils of the same organism found on widely separated continents, which today have very different climates? And why did the same types of rock appear on different continents thousands of miles apart? In 1912, a scientist by the name of Alfred Wegener proposed a very innovative idea on the origin of the continents. Building on the work of previous scientists, Wegener proposed that present-day continents once were joined together in a large supercontinent called Pangaea, which means all Earth. His theory stated that over time, the continents drifted away from each other to their present-day positions. Wegener compiled several pieces of evidence to support this theory of continental drift. Perhaps the most convincing evidence was the geographic fit of the continents. For example, notice how Africa and South America fit together so well. Wegener also cited fossil evidence, stating that fossils of the same organism were found on different continents, suggesting the land masses were once connected. For example, a plant fossil called Glossopteris was found on 4 different continents, including Antarctica, an icy continent where this plant could not grow today. Similar glacial effects on all 5 continents further supported the notion that continents were once connected. Rock structures and even mountain ranges which end abruptly at the edges of continents and pick up on the edge of another continent also provided evidence. In spite of all the evidence proposed by Wegener, his theory of continental drift did not gain widespread acceptance for several decades. Amazing discoveries led scientists to elaborate even more on Wegener's theory of continental drift. Their findings were incorporated into the new theory of plate tectonics. In the theory of plate tectonics, it's proposed that a number of tectonic plates ride across the Earth's surface. What is a tectonic plate? Tectonic plates are made up of the crust and upper mantle, which when combined make up the lithosphere. The thickness of the plates can be compared to the thickness of the skin on this apple. Plates vary in thickness, but average around 100 kilometers thick. The lithospheric plates are less dense than the hot, partially molten mantle below, and float on top of the denser asthenosphere, much like ice floats on a lake. There are 7 major lithospheric plates. In many cases, lithospheric plates carry continents. The largest plate is the Pacific Plate. There are a number of other smaller plates, including the Juan de Fuca Plate, located off western North America. The way plates move in relation to each other is responsible for many of the exciting geological events and features we experience on the Earth's surface. Plates are in a constant state of slow motion. 2 plates interact with each other in one of 3 ways. They can move away from each other, move toward each other, or slide past each other. The arrows on this diagram of the lithospheric plates indicate the direction the plates are moving at some plate boundaries. This city by the bay is San Francisco, California, known for the Golden Gate Bridge, spacious, well-manicured parks, and quaint neighborhoods. It's regarded as one of the most beautiful cities in North America. But early on the morning of April 18, 1906, this city turned into a disaster zone. A powerful earthquake shook the ground, toppling buildings and turning them into rubble. Large fires, which were ignited as a result of the earthquake, raged for 3 days, burning over 28,000 buildings to the ground. The devastation left over 350,000 people homeless. Today, the people of San Francisco and the surrounding area regularly feel small earthquakes. Many nervously anticipate a large earthquake, referred to as the big one, an earthquake which would be as powerful as the 1906 quake. While scientists predict that a large quake is imminent in the near future, no one knows exactly when the Earth will be jolted. How are earthquakes caused? How are they measured? What is an earthquake? An earthquake is the movement or shaking of the ground, resulting from sudden movement between rock masses in the Earth's crust. Strong forces within the Earth's crust may cause rocks to bend and to build up stress and tension over time. When stress exceeds the strength of the rock breaks or moves along planes called faults. This sudden movement in the Earth's crust generates waves of energy, which travel outward through the ground. It's a process similar to throwing a pebble into water. Notice how small ripples travel outward in all directions. In many cases, the amount of energy generated by an earthquake can't be felt at all. But in some cases, the earthquake can be powerful enough to cause intense property damage. One of the strongest earthquakes ever recorded in North America occurred in Alaska on March 27, 1964. People were just settling down to eat dinner when a massive jolt shook Anchorage and the surrounding region. One woman, running outside to find her children, fell into a crack in the earth, facing certain death, only to be thrust upward by the continual shaking of the earth. The earthquake epicenter was located about 130 kilometers southeast of Anchorage. The epicenter is the point on the Earth's surface directly above the point underground where the earthquake originated. The point beneath the surface where the quake originates is called the focus. Sometimes earthquakes occur under the ocean. Seismic waves produced by earthquakes can be detected and recorded by instruments called seismographs. The zigzag line made by a seismograph, called a seismogram, enables scientists to determine the time, epicenter, and focal depth of an earthquake. Generally speaking, the higher the line, the stronger the earthquake. The Richter scale is one method used to calculate the strength of earthquakes. For each increase of 1.0 on the scale, the amplitude of the surface waves is increased 10 times. For example, the 1964 Alaska earthquake had an estimated magnitude of 9.0 on the Richter scale, 100 times greater than the 1989 Loma Prieta earthquake, which had a magnitude of about 7.